So hi guys, we have another topic here, and this is our problem. A spring is such that 20 pounds weight stretches it 6 inches. There is a damping force present with the magnitude as at the same time as the magnitude of the velocity. An impressed force 2 sine 80 is acting on the spring. If at t is equals to 0, the weight is released from the point 3 inch below the equilibrium point. Find its position for t greater than 0. So to find the position of the weight for the t is greater than 0, we need to solve the differential equation governing the motion of the weight on the spring. So let's find some variables. So xt and is k b. So itong xt natin, ito siya represent the position of the weight at time t. So yan siya. Itong m naman natin is yung 2 pounds. 2 pounds is the mass of the weight. So yung k is the spring constant, and b is the damping constant. So the equation of the motion for the weight is given by Newton's second law. So we know that m times x double prime t plus b times m times x double prime t plus b times x prime t plus k times x of t is equals to ft. So itong xt natin is the second derivative of x. Yung x double prime natin, second derivative. X double prime t, second derivative ng xt natin. And this x prime t is the first derivative of xt. Yun, parang derive lang natin yun siya. And the, ft is the impressed force acting on the spring. So in this case, the impressed force ft is given by the ft is equals to 2 times sine 80. So ft is equals to 2 times sine 80. Now let's solve the differential equation. So step 1, find the values of k and b. So k and b equals to yan. So given that 2 pounds weight stretches the spring by 6 inch, we can use Hooke's law to find the spring constant k. So we know that diba na force is equals to k times x. So yung F natin is 2 pounds and k is wala pa. Yung x naman natin is 6 inch. So k times 6 inch. So 2 pounds is equals to k over 6 over 12 feet. Kasi kalahati. 1/2 yan siya. 1/2 lang yan. So 2 pounds is equals to k over 2 feet. weight. So, lipat of h equals K over 4 pounds per feet. Yan. So, the magnitude of the damping force is equals to the magnitude of the velocity. So, we can write it as dito na lang. Dito. We can write it as B times x prime of t equals to m times x prime of t. So B is equals to m is equals to 2 pounds per feet. And step 2, rewrite the differential equation. So plugging in the values and the differential equation becomes B2 is times x prime of t plus 2 times x prime of t plus 4 times x t is equals to 2 times sine of 8t. And step 3, solve the differential equation. So to solve this differential equation, we can assume that the solution from xt is equals to a times sine 8t minus phi. So xt is equals to a times sine of 8t minus phi. So where a and phi are constant to be determined. So taking the derivative, we have xt prime so is equals to 8a times cosine of 8t minus phi. Second derivative, negative 64a times sine 8t minus phi. So substituting these variables or derivative into differential equation, we get 128a times sine 8t minus phi plus 16a times cosine of 8t minus phi plus 4a times sine 8t minus phi is equals to 2 times sine 8 of t. So now we can equate the coefficient from the of sine 8t and cosine 8t, separate to find a and phi. So for sine 8t, we can write it as 28 times sine 8t minus phi plus 4a times sine 8t minus phi. is equals to 2 times sine 80. So simplify natin to. We get minus 4. So 124 under the 4a times sine 80 minus phi equals to 2 times sine 80 or sine 80 minus phi is equals to negative times 1/64. So since 80 minus phi is equals to sine times negative phi plus 80 is equals to sine phi minus 80 using the property sine negative x, so equals negative sine x, we have sine phi minus 80 is equals to 164. So this implies that phi minus 8 is equals to arcsin 1/64. So phi minus 80 is equals to arcsine 164. So for cosine 80 naman, cosine 80 cosine, so 16 cosine. Okay. So 16a for cosine 80 naman, so 16a times cosine 80 minus phi is equals to 0. Since cosine 80 minus phi is equals to cosine negative phi plus 8, so it is equals to cosine phi minus 80 using the property of cosine negative x equals cosine of x. We have cosine of phi is minus 80. This is equals to 0. So this implies that phi minus 80 is equals to pi over 2. So cosine phi minus 80 is equals to pi over 2. So to solving the equation phi minus 80 equals arcsine 1/62. So solving the equation phi minus 80 arcsine 1/62 and phi minus 80 is equals to pi over 2. Simultaneously, we find the value of phi. So getting the value of phi, phi minus 80 equals arcsine 1/62. Phi minus 80 is equals to pi over 2. So from the second equation, we got phi we get phi is equals to pi over 2 plus 8t. So substituting this value of phi in the first equation, we have pi over 2 plus 8t is equals to minus 80 equals to arc sine 1 over 62. So, ganun sa kabila. Phi is equals to 2. Matanggal na to. Tanggal. So, 0 is equals to arc sine 1 over 62. So, using the inverse sine function, we find that pi over 2 is approximately equal to 1. Telling in my calculator, 1.5708, so radians. So p over 2 is equals to 1.5708 radians. So therefore our phi is equals to pi over 2 plus 80 is equals to 1.57 plus 80. Yan. Narito na siya. So now we have the value of phi. So we can determine that the value of A is sine phi minus 8t is equals to 1 over 62. So sine equals to 1.5708 minus 8t is equals to 1 over 62. Wait lang. Plus 8t minus 8t is equals to 162. So sine 1.5708 equals to 162. So yun. Using the value of sine for phi for pi over 2, we find that A natin is equals to 1 over 62. So finally, we can write the position of the weight as the function of time. So solving for the weight, the function of time, we get to have xt equals to A times sine 80 minus phi. Substitute lang natin yung mga 1 over 62 times sine 80 minus 1.5708 plus 80, get to have xt equals to 1 over 62 times sine negative 1.5708. So xt is equals to negative 162 times 1 is equals to negative 1 over 62 x of t natin. So, therefore, the position of the weight t greater than 0 is negative 1/62. So, this is our final answer.